So we continue our analysis of the logit model for multiple alternatives. We have 3 ingredients. So we already looked at the choice set, where we talked about the fact that it's universal or individual specific. We looked at the epsilon in, the error term, where we assumed that they are IID extreme value distribution. And from this assumption, we derived the model. We derived the concrete logit model. And now we will focus on the last part, the deterministic part of the utility function, VIN. And this is an important part because this is where we will translate our behavioral assumptions about the choice into mathematical expression. So what we will try to do in this video is to get a sense of how we can code our assumptions using this VIN function. So this function, VIN, is actually a function of the variables that we are considering. We call these variables the explanatory variables because these are the variables that explain the choice. And we identify 2 categories of variables. The first categories are the attributes of the alternative. So we will denote them by ZIN. We have 2 indices because they vary across alternatives and they vary also across individuals. The second set of variables is denoted by SN. They are the socioeconomic characteristics of individual n. These variables do not vary across alternatives I. So this is why Sn has only 1 index n. So the utility function, the deterministic part of the utility function, will be a function of all these variables, the ZIN and the Sn. But what function? What is the functional form? The first thing we will do to simplify the notation is that we will put together all these variables, ZIN and Sn, into one vector that I call XIN. This will simplify my notation. So when I don't need to make the distinction between the attributes and the socioeconomic characteristics, I call them X, which is the general variable of the model. Now the most common specification of the utility function is what we call a linear in parameter specification. In this case, the VIN is simply a linear combination of these variables. And the coefficients of this linear combination that we denote here by beta k are actually parameters, unknown parameters that we will have to estimate using observations. Well, using a linear representation may seem kind of arbitrary. Life is not linear. And actually, we are talking about choice, about behavior. It's relatively difficult to believe that behavior can be modeled using a linear specification. Well, as we will see, making this assumption, which is mathematically convenient, is not as restrictive as it may seem. And we will see why. Before we look into the details, I ask you to do the quiz which is proposed on the web page so that you can get a sense of the interpretation of this linear in parameter specification. And then go to the next video where we'll look into the advanced details.